Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 4 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3640, Trionic Array Part 2. So yesterday we solved Part 1, right? Problem number 3637. And today we are going to solve the Part 2 of this problem. So this problem is marked hard by LeetCode, but I will make sure that this problem you will find it very easy after understanding what we need to do. Actually, this problem is easy actually. Okay, so don't worry. So in this problem, you are given an integer array nums of length n. A trionic subarray is a contiguous subarray from nums L to R, where L is greater than equal to 0, L is less than R, and R is less than n, for which there exist indices like L is less than P, P is less than Q, Q is less than R, such that nums of L to P is strictly increasing, nums of P to Q is strictly decreasing, nums of Q to R is strictly increasing, just like yesterday's problem. But in this problem, we have to return the maximum sum of any trionic subarray in nums. So sequence is like this: strictly increasing, strictly decreasing, then strictly increasing. But in this problem, in a given array, we may have many sequences like this. Many sequences like this: increasing, strictly decreasing, strictly increasing. So among them, we have to find the maximum. So maybe here I'm getting S1, here maybe I'm getting S2, here I'm getting S3. So wherever I have to just return the max of all this, let's say. So this is what I need to do here. And if you see the constants, so n is equal to nums dot length, and n is greater than equal to 4 and less than equal to 10 to the power 5. So definitely we can't solve this problem in O of n square. We will try to solve this problem in O of n. Okay, and here nums of I value is from minus 10 to the power 9 to 10 to the power 9, and it is guaranteed that at least one trionic subarray exists. All right, so now here let's understand this with this example number 1. So here strictly increasing, so 0 and strictly increasing, right? Strictly increasing like this. So 0, then minus 2. So minus 2 is not greater than 0, no, so I can't start from here. So let's start from minus 2, maybe minus 2, and minus 1 is greater than this minus 2. Yes, good. Minus 3, no. So let's say this is one increasing slope, you can say here increasing. All right, then here minus 3. All right, minus 3 is smaller than minus 2. Okay, minus 3, done. Then 0 is smaller than minus 3, no. Okay, then after that we have 0. All right, so here let's say I write 0, then 2. Okay, 2 I will write here. Minus 1, no. So this is one valid sequence, right, that we need to find. A trionic subarray is a contiguous subarray. So yeah, this is valid. So here let's say if I just give the indexing here, so 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, 6 index. So here you can say minus 2, from here I'm starting now, you can say this is your L at 1 index. Then P, you can say it's at this position, right? And then at 3 you may say that let's take this as Q, and R you can say it here at 5 index. So this is valid na. L is equal to minus 2, here minus 1 P, and minus 3 Q, and here 2. Okay, at 5 index. So here if you see, L is less than P, P is less than Q, Q is less than R. So these all indexes are valid. This thing is valid. Clear this part? Now in this, if you just calculate the sum, so minus 2, and then plus minus 1 plus minus 3 plus 0 plus 2. So overall sum is minus 2 minus 1 minus 3 minus 6. Minus 6 plus 2 is minus 4. So that is your output. That's it. That's it. Okay, right, this is clear. Now here if you see, we have to find something like this, right? These shapes. So definitely this part, if you see, this is fixed, we can't modify it, we can't modify it in this. But definitely we can modify this part, we can modify this part. Why I'm saying that, why I'm saying that we can modify this part and we can modify this part, and this part is fixed. Okay, see here, see here. So for a increasing slope, right, so you need at least two elements for increase to show it increasing order. Okay, and let's say this is some decreasing slope, let's say it is fixed, and for increasing slope you need at least two elements like this. Okay, now here, let's say this value is 1, let's say. Okay, let's say this value is 2, let's say this value is 1, and let's say this value is 2. Okay, let's say, or yeah, let's say 2. Okay, now in this case, what is the overall sum you are getting? 1 plus 2 plus 1 plus 2. 2 plus 1 3, 3 plus 1 4, 4 plus 2 is 6. 6 is you are getting. Okay, but let's suppose you can also start from here, na, from this point also you can start. Let's say it is 0. Okay, then also you are good, then also it is a valid shape, na, again 6. But let's suppose here you have minus 3, this is also valid, this is also valid shape, right? Because we can have negative values for nums of I, we can have negative values, so this is also one valid shape. So in this case you are going to say your sum is minus 3 plus 0 plus 1 plus 2 plus 1 plus 2, and that is minus 3, it will be 3, right? 6 and minus 3, yeah, 3. But this is wrong, this is wrong. Let's not start from here, na, let's start from here. Why we need to include this? This is also valid shape, na, for this particular decreasing slope, and this definitely it is increasing and it is increasing. For this decreasing, if I fix it, for this increasing, let's take it starting from here. Now why I have to take it starting from here? Because it is decreasing the sum and I don't want this. So I hope that this part is clear. So what I will do here, I will just fix 2 points for increasing, and whatever decreasing I am getting here, let's say this is peak 1, let's say this is your valley, and after that I will move to this side with just, I will keep just 1 point here, let's say uh some point x. Okay, now after that, I will try to extend to increase the sum. After that I will try to extend to increase the sum. Okay, but this part is should be fixed, this part 2 points here, this and here some valley, and in between you can have any number of points, and this point it should be fixed, and only after that I will try to extend it to increase the sum, right? I don't want to start from here to keep this lower sum, right? Okay, let me show you a few more examples here. Let's see this example here. Oh, calculation a little bit difficult. Okay, no problem. So here starting from 2, and then you have 993. Okay, we will do the calculations, negative calculations. All right, and then we have minus 791. Okay, minus 791. Then minus 635 is bigger than minus this. Okay, so let's say I am writing here minus 635, and then minus 569 is also bigger than minus 635. Here minus 569. All right, now here what is your output if you take all this? Okay, see, you are clear, right? This is value 2, then 993, this is increasing, then 993 to minus 79, it is decreasing, then minus 79 is smaller than minus 635, increasing, and minus 635 is smaller than minus 569, so it is also increasing here. So okay, so now in this case you are going to tell me that your sum is, let's do the calculation, huh? I also don't know that sum as of now. So 995, and then here 791. Okay, this is negative, right? So let's subtract it, let's do step by step. 5 minus 1 is 4, 0, and here I'm getting 204. Okay, now from this 204, let's subtract minus 635. Minus 635. Okay, plus and minus 635. So that simply means 635 and subtract 204. So what you are going to get here? You're going to get 1, 3, and 4, minus 431. You are getting minus 431. Okay, now in minus 431, if you add minus 569, what you are going to get? Minus 431 and here minus 569. So that simply means uh, we have to do some addition here. 9 plus 1, 10. 6, 7, 8, 9, 10. Here 5, 4, 9, 10. Okay, 1000 minus of 1000. Okay, minus 431 minus 569 is nothing but minus of 1000. Clear this part? Clear this part? But minus 1000 is not my output here. It is minus 431. That simply means I am just taking this part here. This, and this. That's it. I'm not taking this minus 569. So from this example, I proved that here also we need to check like this. Then only, like, first we have to fix 2 points and then only we need to extend. And in this example, I proved here in this side also that we need to extend. This is fixed. Okay. Now one more edge case. This example, let's say in this case, first you are trying with 1. Okay, then you are taking 4, and then you are taking 2, and then again 2 na. This is wrong. This is wrong. It should be strictly increasing. It should not be same. So this is not a valid. Okay, so we have to keep this thing in mind as well. Okay, so here in this case, maybe you are starting with, let's say, 2, this 2, and then 3, then 1, then 2. So 2, 3, 5, 6, 7, 8. So 8 is the output. So this here it is saying strictly. Strictly means this strictly means that it should be greater than, it should not be equal, right? So increasing, if it is just increasing now, so then this is valid. But if it is strictly increasing, then it is not valid. For strictly increasing, all the values should be strictly increasing, should not be same. Okay, so I hope that you guys are clear. So these are the things I need to take care. All right, so now let's write the code and let's side by side understand. Okay, so that's what we are going to do now. Okay, so same story, whatever explained, I'm going to do the same thing. But yeah, understand this code also, how I'm going to write, and I will also explain side by side what is happening. So here int n is equal to nums dot length. This part is clear. Then answer in long we have to return. So here we need to return the max value. So here I'm taking the main initially, main underscore value. And then after that, so we can have different start points, right? So we can have this as my starting point, we can have this as my starting point, we can have this as my starting point. Okay, all this stuff, all this can be my starting point. Okay, from here also I can try to start, from here also I can try to start, from here also I can start. Here if you see, this is one start point, this is one start point, this is one start point, right? So we can have different starting points. So for that, what I will do here, I'm going to run one loop. I will say for int start is equal to, initially I'm saying from 0, let's start, and start is less than n, and here start plus plus. So here I am starting from different points, and for different starting points I am calculating the sum, and in the end I am taking the max sum, right? So here first what you need to do here, let's say int index, and I am just keeping it at start. As of now it is index value is fixed at start. Now here first increasing segment, first increasing segment, first increasing segment. So here what I will do, how we are going to check? So simple na, while index plus 1, the next index, it should be less than n, so that I don't go out of bound. And here I will say nums of index value, right? Nums of index value, if it is smaller than the nums of index plus 1, that simply means that it is increasing. The next value, it is greater than the previous value, right? In that case we have increasing slope. So here I will say index plus plus, increasing segment. Now I'm doing index plus plus. So here let's say you have some example like this: 2, 4, 5, then 3, and then 2, then maybe let's say 4, then maybe 6. So here this and this you are comparing, okay? Then this and this you are comparing. So 2, then 4, then 5, and then this and this you are comparing, okay? So right, this will fail here, okay? This will fail here. So as of now you are here, okay, at this particular position. So here, just if I just give the indexing 0 1 2 3 4 5 6, okay? So here what I will do, I will say this is your peak 1. Let's say peak 1 is equal to idx. So you haven't incremented the index here when this is the case, okay? So right now you are here. So I'm just saying that this is nothing but your peak as of now. This is your peak, right? So this is clear. Now for this increasing, at least 2 points should be there, na, for this to be increasing. If we have just 1 point, then it is not increasing slope. But if we have 2 points like this, then it is an increasing slope, okay? So here what I will do, I will say need at least two elements. So here I will say if the peak of 1 is equal to start. So my start is 0 as of now, and my peak 1 is, if it is also 0, then definitely that simply means we have just 1 point, okay? So in that case we have to skip, we have to just continue, we move to next start, okay? This part is clear, right? Now after that, here we have to do, we have to find out the decreasing segment, okay? Decreasing segment. So here I will say decreasing segment, right? Now for decreasing segment, right, for decreasing segment I have to go like this, but here I am fixing 2 points. I am fixing these 2 points. I'm not taking this complete 2 4 5. I told you here that let's take only 2 points here, and then decreasing slope we will take, and here also we will take 2 points. Then after that I will extend. So from here, if I need to pick 2 points, that simply means I will pick 4 and 5. So 4 plus 5 I need to do. That simply means what I will do, in the sum I will add this 4 and 5. So here I am going to write long sum is equal to nums at peak, okay? At this value, what is the value I have? Peak 1. All right, here peak I'm taking, okay? And plus nums of peak minus 1 I'm taking. Done. So sum I have taken here. Now next time, let's do one thing. Let's move your idx value to this point for decreasing slope. I'm going to check. So here I will do idx plus plus. Done this part. Now again I will run one loop while idx is less than n and nums of previous value idx minus 1, previous value, so 5 and 3 I'm going to compare now. So 5, it should be, what I will say, it should be greater than this 3. So here I will say nums of index minus 1, and if it is greater than nums of idx. So in this case, for decreasing slope I have to add all the members. So in the sum I will just increase the value of nums of idx. So this is fixed, and idx plus plus I'm doing here, idx plus plus. This is done, okay? Now Here if you notice, uh, my idx I'm going to compare this, then here 2 4 5, then 3, then I will take 2, then after that I'm going to compare this, and then after that I'm going to compare this 4. So my idx reaches here. Okay, because here if you see, I am first incrementing the index and then I am comparing the previous value. So with the 4 I am comparing this, so right now it is false, so my idx is here, but my value is at this 2 point. Okay, this 4 index, my value is at this. Okay, value is at this point, peak is at this point, peak peak 1. So here what I will do, I will say int value is equal to idx minus 1, right? Clear why I'm doing idx minus 1? Because here we are comparing the previous value, right? Idx plus plus, and then we are comparing the previous value. So idx is moving one step ahead, so I just fix it here, right? Now after that, this is done. Now after that, one scenario is like this. But if I have this and after that there is nothing, I have nothing after this. Or if we have same element after this, same like 2 here 2 here, same element, so it should be increasing now. So if we have don't have this shape, if we don't have anything, or we have something like this, so in that case we have to just say invalid slope. So here I will say invalid trionic shape. So here if your value is equal to peak 1, right? So in valley also you don't have 2 points, so then it is not a value, it's just we have at peak 1 only, so this is invalid. Or if your value is at the last point and minus 1, then after that there is no shape increasing a segment, right? And here I will add one more point, idx is less than n. My idx is already moved forward, so idx is less than n, and the nums of idx value, if it is equal to say same as nums of value is nothing but index minus 1 as of now, right? So if this is the case, then in that case also what I will do, in that case I will just make uh, my start as this value point. Okay, from here let's move it. Okay, so here I will say start is equal to value I, just make a jump to this, so that I don't calculate the same decreasing segment again and again. So here my start is going to make a jump to the value directly, right? And just continue from here. This is done, right? Now the third increasing segment. So here I will say third increasing segment. So third increasing segment also, here this 1 point is will be fixed. Okay, so here 2 4 5, then 3 2, then 1, here I will see 4, and this part should be fixed. Okay, so if we are moving to the third segment, definitely here we didn't continue, so definitely we didn't continue from here, and definitely we have some increasing value after this. So let's take this value to the sum. All right, let's take this value, because here also we need to fix this point x, right? And we already checked after two cases that after that there is nothing, or after that we have same value, so we have already skipped those part, right? So now what I will do here, in the third increasing segment, I will just update my sum as sum plus nums of value plus 1 I will do. All right, so this is what I had it. Now this is done. Now next part is nothing but the maximize third segment extension, the first segment extension we have to do. So now it will be same code only, nothing difficult. So here I will write maximize third segment extension. Okay, maximum third segment extension, right? So here let's say long max extra is equal to 0, running is equal to 0. So two variables I'm taking, nothing else. And here I am starting from value plus 1. I have already added the sum, and now I'm starting from value plus 2. So I loop is starting from int, let's say I is equal to value plus 2, right? And here I is less than n, and nums of I value is greater than the nums of I minus 1 value, and here I will just do I plus plus, right? So that simply means it's increasing. So running sum is going to be this plus nums of I value, and the max extra I'm just going to update. So I will just take the max sum here, math dot max of the max extra sum by doing the extension or running sum. So I will just keep the max extra max value, right? And that value I will just update to the my sum is equal to sum plus max extra. So this is the logic I'm going to use. So running sum I'm calculating, and in max extra I will always store the max value of max extra or running value, whatever we are going to get, and that value I'm going to add to the sum. That's it. So this maximize third segment extension. Now same thing we have to do for first segment extension. So here I will say maximize first segment extension. So again we have already assigned the values, right? Long, max, extra, and here. So we don't need to create a new variable. Same variable I'm just assigning, keeping it to 0 again. So max extra is equal to 0, and my running is value is also equal to 0. Done. And now after that what I will do, here int I is equal to peak 1 minus 2, I would say this time peak 1 minus 2, and here I will say greater than I is greater than equal to start value, and here I will say I minus minus. That's it. Only these things I need to check. From start we are moving, okay? So it will automatically take care of the values. And here running is nothing but running plus equal to nums of I, max extra will remain same, and in the sum I will just add the max extra. So this is done. All right. Now after that we have to just update the answer. Update the answer. So answer is nothing but it is going to be the max value. So I will say math dot max of the answer value that you have calculated until now, and the current sum you are getting, whatever the max, you have to update it to answer. And we have to always skip the processed region for the next iteration. Skip processed region. So here I will say start is equal to value, and here I will just do -1. Reason is because I'm running this for loop, and here start is also incrementing now, start plus plus. So if I just pass value -1, so it is automatically take value only. So from next value I will start, right? So here this is one shape, okay, but maybe after that we have something like this. So for this one, this as start and this as end. Next time I'm going to take this value as my starting, this also valid na, this part. So like this. So that is why I'm doing like this, okay. And here that's it na, that's it. Here you have to just simply return answer, right? Now let's run it and see if the encodation will try to fix that. So yes, there are some issues, so let's fix that. Here we are getting some issue. So peak 1, it should be peak 1. Let's run it again. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.